Moving on to page 5, and this is actually question 20. We want to simplify this square root expression. So I wrote it out over here. The w squared was out in front. 7 doesn't simplify. W doesn't simplify. I split it up, coefficients and variables. V squared, that's going to simplify. And then over here, took the 28 and factored it into the nice perfect square 4. 4 times 7, 28. And as always with the variable and the square root, we want as large as possible even exponent, so it's divisible by 2. So there's the rewriting. And now the simplifying, the square root of v squared becomes v. These two still stay under the square root symbol. Square root of 4, of course, becomes a 2. And square root of 7 stays under the radical. Square root of w to the 4th, 4 divided by the invisible 2, we get a w squared. And the square root of w stays under there. After we clean this mess up, this is done already. This 4 times 2 we make into an 8, and the v w squared, I put the w squared in front just to make it look more like its partner over here. At this point, can we subtract? Yes, because these are a perfect match. We have 1 of these minus 8 of the exact same thing. 1 minus 8, negative 7 of those. It's a mouthful. W squared v square root 7w. In question 21, said to simplify this product, it's this square root times this square root. Simplifying these individually is kind of a waste of time and a mess. If we multiply them together, we get this, 75, which you might recognize from previous work, splits up nicely into 25 times 3. Nice perfect square, 25. That's already got an even exponent. This we break up into the largest possible even exponent. So square root of 25 becomes a 5. Square root 3 stays under there. Square root w to the 6th. We divide 6 divided by 2. We get w to the 3rd. And the u to the 4th, the square root of that. 4 divided by 2, we get 2. And this leftover u stays under there. There's our final answer for question 21. Question 22, one of the more challenging things in this whole collection of exercises. We've got this equation to solve with a radical on both sides. So we can only isolate one radical at a time, but if we isolate this radical, it was given to us with that one isolated, square both sides of that. On the right-hand side, very simple, you just get rid of the square root. On the left side, doing FOIL over here, there's the meaning of squaring it, multiply it by itself, 9 times 9, and then 9 times minus square root x, and then minus square root x times 9, so there's 2 of those there, and then plus square root of x squared. So the square root of x squared, of course, just becomes an x. These two things in the middle, minus 9 of them and minus 9 of them, gives us a grand total of minus 18 of them. What happened from here to here? I just took away 1x from both sides. Got a lot cleaner looking. Then I take away 81 from both sides. And then I divide both sides by negative 18. And now I want to get rid of that square root. Just square both sides, and I get plain old x equals 7 squared, or 49. And if I go back to the original equation, plug in 49 for x, this will say 9 minus square root of 49, which of course is 7. It'll say 9 minus 7 on the left side. On the right side, 49 minus 45 is 4, so it'll be square root of 4. 9 minus 7 is 2, square root of 4 is 2, so that works just fine. Question 23, I want to solve this by completing the square. So the first step is get the x term separated from the number term, so I subtracted 50 from both sides. Then, and since it's just 1x squared, it makes it pretty simple. Take half of this coefficient of x, take half of the b and square it. That tells you what we're going to add right here. Half of that would be -8. -8 squared is +64. So I add 64 on both sides. And now this is a perfect square trinomial. It can be rewritten, same letter, same sign, half of that squared. X minus 8 times x minus 8 is exactly that. On the other side, -50 and 64 is 14. Then we take the square root of both sides, and the square root of the square of that just leaves us the x minus 8. On the numerical side, plus or minus the square root of 14. And finally, since that's -8 there, I add 8 to both sides, and I get this. 8 plus root 14, 8 minus root 14 are the two solutions. That's the end of page 5.